You can't see. One moment. Now you can see, no? Right?
Yes, sir.
Right. Okay. Now this is the question we left. Uh, at this point, we left there in the last class, right? Steam at 20 bar, 360 degree centigrade is expanded in a steam turbine. So you have to recall the boiler and the turbine in the circuit, and then pressure. Now you can see from 20 bar to 0.08. Why? This is expansion. Expansion means pressure is reducing, right? Now it then enters a condenser, right, where it is condensed to a saturated liquid water, and then pump it. So now water pump, that is the compressor we have discussed over there, feeds back the water into the boiler, right? That is the circuit and the values for the paper power cycles. Now, question number 1 is assuming ideal processes. Find per kilogram of steam, because the steam table is available per kilogram value, right? And the network and the cycle efficiency. At least the first question. Now we will see question part A. Now, first of all, I have to work out part A. You can see if you cannot see this, you will not see this question again when I work out problems, because I am going to work out these things in a whiteboard, right? So you have to get a screenshot, then only you can read the question, right? Okay, because I have the question paper, it means I can read, but you cannot, right? So take a screenshot or whatever it is, you can take down if you want, right? I will move to the whiteboard, right? If you cannot see the whiteboard, then you have to tell me. Now you can, I think, no? It is visible, no? Right now, first of all, you can see I will draw the steam table also. If you have the hard copy, then you have to keep that with you, right? I will draw the circuit first. Somewhere here, TS diagram. As I told you, now you can see TS diagram. So these are the pressure, like constant pressure lines, right? Then this straight line, because I'm using over here. Now you can see say this is these are the constant pressure lines, constant pressure lines. So this is P1 20 bar, P2 08 bar, right? So this is now, this point is 1 now. according to our diagram now, this is now, say, we will name this point as 2s because ideal, if it is ideal, 2s, actual is different. So now here 3, here 4. For the ideal value, actually, I will put S here, 4S, straight line, right? For the actual thing, actually, that is for the second part. First of all, we will see, right, 360 degrees centigrade. Now you have a question with you. Here, 360 degrees centigrade. Now, this is temperature. This is entropy, right? Entropy, right? So this is the diagram, and then why these are the straight lines, vertical lines, because I cannot draw, because next time I will take a screenshot and then put you for your reference if you confused with the lines, because these lines and these two lines are vertical lines, because first question is so I will put the arrows also now here from here. So this is the one. So that is the cycle. 1, 2, 2 is not there. 2, 3, 4, and then 1 again. Right? Now that diagram you have to recall the Rankine cycle. Rankine cycle. Right? So first of all, now we will see, right? Enthalpy values are very important. We are going to use the values, H value from the steam table, and then S value, right? What is H? Enthalpy. What is S? Entropy, right? Then from the steam table, now I am going to the refer the steam table. So you have to keep the steam table with you, then only you can work out, right? Then originally, now this is the ideal cycle. Sometimes actual cycle, I will change color. Actual cycle, what will happen now? Real cycle or actual cycle, somewhere here I will put it. Somewhere here. Then I will use the different color. This is, suppose I can put this point as 2. That's why over here, here also now you can see actual cycle will goes like this. This is, suppose we will put as 4. So actual cycle is 1, you can see 1, 2, 3, 4. Ideal is 1, 2s actual. Now, actual cycle. Actual is 1, 2, 3, 4. Ideal. Ideal means we imagine. This is ideal. Ideal is 1 from 1 to 2s, 3 to 4s to 1 again. Right? It will go again like this. Right? Here also. So first question, actually assuming ideal process, right? Ideal process. Now we will work out the ideal process first, right? For that you can see right? Ideal cycle. Assuming ideal processes, find per kilogram of steam the net work and the cycle efficiency. Okay. Now you can watch here. What you can do is, first of all, H1 value. Now you can see at 20 bar. So let's change the color. Right? Over here I can write 20 bar. 20 bar, 360 degrees centigrade. So you need to find out the values for one. Now this 0.1, that is superheated area. Superheated area over here. Here liquid plus gaseous. Here fully liquid, right? That actually you should know. So at 20 bar, 300 degrees, 60 degrees centigrade. Now you can ask me, so how can you say that is superheated steam? Now you can see 100 degrees centigrade. If the water is 100 degrees centigrade, then actually it is actually the point actually at 100 degrees centigrade. After 101, what will happen? It will start to vaporize, right? So that's why we are calling that as steam. And then if it is 360 degrees centigrade, then superheated, right? That's why we are calling that as superheated steam. 0.1 is actually superheated steam. So values, first of all, we have to find out the H value and S value. Here actually you can see we have to go for mathematics also. Now I have to share the table now. Now I will show you that you can the new. I will go to the new share for the steam table. Where is the steam table? Can you see the steam table? Right? No, 1 moment. Can you see now? Okay, right. Okay. Now you can see 20 bar, 360 centigrade. Now you can see, I will go to the superheated table. So superheated is available. Now you can see from the table, now saturated. This is saturated. Now over here, now superheated, right? Superheated steam. Now over here, superheated, but you need the value. Pressure is 40 now, right? But you need 20 bar, no? 20 bar. Saturated. No, see, this is saturated. Saturated, superheated, right? Superheated. Value is 20 bar, 300 degree, 60 degree centigrade, right? That is page number. Second one. It comes over here. Now you can see pressure is 20 bar, right? This is pressure. This column is 20 bar. And then over here, now you can see temperature. Now this is pressure, here temperature 200, 250, 300, 350, 400. But you can see in between you have the temperature 350 and then 300, here 400. 20 bar is here anyway, right? 20 bar is here. But thing is, you don't have 360. Temperature 360 you don't have. Then you have to go for the interpolation, right? Mathematical interpolation, you know, because here 20 bar, now values are here anyway. Now you can, for 350, H values, you should know H values. Here 360, H value 3138, and then 31. So I will write all these here, right? Interpolation. Now mathematical, you have to go for the mathematical interpolation here. So then I will write the values here. Now I have to, you can keep the table with you because I have to go to the other for the steam, the whiteboard. I have to move to the whiteboard, then only I can work out, right? I just wanted to show you the value because for all values, 20 is available. But here, VG, UG, HG, SG are there anyway. That is these values, you know, entropy, enthalpy, internal energy, like that. You can read, but you cannot read the value directly from the table for the given state. That is 20 var, 360 degrees centigrade. Right? For that, you have to go for the interpolation. So I have to write the interpolation. I need to write the interpolation in the whiteboard. So I have to move to the whiteboard now. So I will stop this. Yeah, I have to go to the whiteboard again. Right? You can see the whiteboard now. Right? Now you can see 20 bar 360 centigrade, but the value interpolation now, if you are not familiar with this, because then you have to interpolation. I will write here, you can see say 350 20 bar pressure is 20 bar, but temperature you have 350 degrees centigrade. Value, we will write the value also. Value is 3138 kilogram per kilojoule per kilogram. That actually, you know. One moment. Right? And then for 360, actually, you don't have the value for 360. You need to get the value for 360, but 400, it is available. That is 3248. From the table, I am reading this one, these values. And then 360, now you need the value. What thing is 20 bar. From 20 bar, we are reading at 20 bar, 350 centigrade. The value for H is H value. This is an enthalpy value. Enthalpy is 3138. And then for 400 degrees centigrade, 3248. Right? But you need the value for 360. Now here for this, actually we have to go for the interpolation, mathematical interpolation. Now only one time I can explain. Now you can see for that what I can do is, now we need this value. For this, I will put this one as x1. Here x2. Here we will put x. Here this value is y1. This side y2, but y you have to find out. Y value you have to find out. From mathematical interpolation, now you can write y minus y1 upon x minus x1. X1 is equal to y2 minus y1 upon x2 minus x1. That actually you know. Then I will write directly the equation for the y for the value. Otherwise, from your programmable calculators, I don't know, sometimes it is available, right? Some of you might have experience even for the interpolation. If you are from, this is the faculty course. If you are from electrical or computer engineering, then you must have this experience also for the interpolation, right? This is the value. So to find out y, you can substitute all values, right? I just substitute just to show you the interpolation. Otherwise, you have to find out these values very. X is 360 and then 350. Then this is 3248 minus 3138. Sometimes these X values from other tables differ little bit only little bit, not much. 400 here, 350, right? From this actually you can calculate 51, say 31, I will round it, 3160, right? So original value 60 kilojoule per kilogram. So that is the so mathematical interpolation from this steam table. You should know there is a step to find out for the now if you are if they are giving the equation the question with this interpolation, then the problem actually will not carry more parts. Otherwise, within half an hour you have to complete, no, right? So now you have to familiarize with this interpolation also to find out the values. Now I am going to work out quickly, right? The problem. Can see I will change the pen only. That is the y is actually h1. H1 is h1. Actually, this is h1. H1. So h1 original value from other table, some other interpolation now 3160 kilojoule per kilogram, and then same thing you can same interpolation now you can read you do for this entropy also, same interpolation 6.9917 kilojoule per Kelvin, and then H3 what is H3? H3 directly you can read from the value, because it is H3 that corner, this corner actually this is fluid state, that is HF at P2. HF at P2, P2 means 0.08 bar, 0.08 bar. Now this value is HF at P2. Now, so you can see from the table that is HF at P2. P2 is pressure 2. So you can directly read the value. Sometimes little bit, sometimes they will round it 174, right? It won't take much these things. And then S3 also now you can see S3 also SF, that is fluid state at P2. Liquid state, fluid means liquid state. Say point, this is from the reading 5926, sometimes 593 they will put kilojoule per kilogram Kelvin. So these values actually should be read from the table, right? those values, if you want, if you are not familiar with these things, then again we will work out problems, right? And then so this value also we need HFG from the steam table. We need that reason we will see later when we work out the problems. Now you can see, maybe I think this is kilojoule per Kelvin. All are the readings from the table, SG here, this point. SCP2 means SG over here, right? Why? The reason, you know, actually you will get to know when we go to the problems. All are the all readings are from the table. Only the interpolation is we get actually these two values, H1 and S1. Directly you cannot read from the table, so you have to go for the interpolation. If it is say 20 bar 350 degrees centigrade, directly you can read. Otherwise you have to go for the interpolation, right? Okay, H3 value. I have to finish this and then show you the table, right? And then now we can see, now there is a question also. Could you upload this Steam PDF file? Already uploaded? Somebody actually, you did not yesterday. No, yesterday I have uploaded, but you did not actually see the profile. It is available under notice. You can download it, right? Steam table is available, right? And then the reason SC P2 SFG also you need SFG. All are direct readings. SFG at P2. Completely worked out problems also I will show you, but first of all I have to show you. Then only you can how to work out. If I show you by doing this worked out, if I show you the worked out problems, now you can see, okay, we can do it like this, like that. You will think, and then you will never work out and see. That's why, right? So these values now directly from the tables, and then VF also now you need. VF means specific volume at pressure 2. That also you can, page number 10, page number 10 of that table, you can see, as I said, you have to multiply by 10 to the power of -2. So that's why you get this value. Meter cube per kilogram. All these values are from the table except H1 and S1, right? So I will move to work out the. So first step is now S1 is equal to S2S. Now that also I can show you over here. As I said, S1 means now table. Now you can see the table axis and the table axis. Now you can see TS. Now here, as I said, this is straight line. So now S1 and here S2S, right? S2S both are same, right? So now I will show you. So why now you can see S1 is equal to S2S. So S1 already found 6 that is 9917. And then now you can equate this one as what is S1, SF at P2, pressure 2 liner, plus X2S, that is dryness fraction, into SFG, that is P at P2. P2 actually within bracket Y. Just to explain, just to show you the steps. Now you can see now this question, why this equation I write like this. Now you can see, I will show you from the diagram. Now S2S, now this ideal cycle, no ideal cycle, right? Ideal cycle is here. Then what will happen? Then you have to put this dryness fraction, because dryness fraction is in this area only. Here HF, SF, here SG at this point, turning point, but in between you will have a dryness fraction. So, right? So that's why I have put this dryness fraction X2S, right? X2S. Then you have to find out the dryness fraction, because values are, you can directly read from the table. SF at P2, that is these values. Actually, you can check with the table later, because I don't have time to show parallelly. Some of you have asked me how to show you the table, right? Now from this X2, you can calculate X2S is equal to 0.838, right? So likewise, H2S also same. X2S you can calculate, because dryness fraction you know. So HF at P2, the equations actually you have to familiarize this equation, otherwise HFG at P2, right? So now what will happen here? Now these values actually you can 388 plus 0.838 1, that value is actually 2187.68. Right, H2S. Now first question is, now you can see first question is work. First question is actually assuming ideal process, find per kilogram of steam, net work, and the cycle efficiency. For the network, actually work input plus work output you have to calculate, right? Work input, now you can see that is pump work, right? For the pump work, actually you can write the pump work as WP, that is work in. WP is H4S, enthalpy difference, H4S, that is minus H3. But H4S, as you actually you did not know, now we can write equation into, now you can see VF at P2 into pressure difference, P1 minus P2. This equation we have to memorize, otherwise you cannot. VF, the value we have already found, calculated now earlier from the table. Now you can read this one, meter cube per kilogram, that is specific volume, pressure difference, actually 20 minus 0. Now I will write it, 20 minus 0.08, that is 19.92. Anyway, I have to understand into Y, that you have to convert that into kilonewton per meter square. Now it is in Pascal, right? But it is in bar. So bar is actually changed by, you can see the final value should be in kilogram per kilojoule per kilogram. That's why, because these kilonewton meter, now you will have kilonewton per kilogram. Then that what is kilonewton per kilonewton into meter? That is Newton meter is joule. That again kilo is multiplied, then kilojoule per kilogram. So now this is the heat pump work input. Actually, work input will be this much, right? Work input is compressor work, right? Again, from this work input now calculated, now we are moving this again by using this relation. Now we have calculated WP. Now again we are going to use this equation to calculate the H4S, right? What is H4S now? H4S is equal to WP plus H3. What is WP? This is H3 from the table. Now H4S, now you can see 175 into 89 kilojoule per kilogram, right? So turbine work, now we are moving to the turbine work. Now you can ask me, so why H4S? Purpose of having the H4S, now you will see again turbine work, WT, yeah, turbine work, that is the work output H1 minus H2S, right? That actually already these values you have. Now 3160 earlier you had anyway. This is 59.3. Earlier you had as 3160. It's okay. 218768 971.62, right? Kilojoule per kilogram. That is turbine work, right? Turbine work. Still, we did not reach the question. So W network output, right? Now, when network output, actually from the turbine work, you had to reduce the compressor because that is working. Now, when you see the system, now if you see system, this is compressor work W in, that is the pump work. This is W out. So work out turbine work. Work output means so you have given to the you have given some of the work to the system also. So that actually that work you had to reduce from the turbine work. Then only net work output you can calculate. So W net is actually WT minus WP. Then you will have the value as, now you can calculate and see 61 kilojoule per kilogram, right? So net work out. Then for now you can see heat supplied, heat rejected. Now you know heat rejected is actually, if you say H1 minus H4S, that is the purpose of having the value H4S. Now over here, now you can see why you, now you can ask me the purpose of calculating the value H4S, right? Because ideal cycle, then you have to find out this value. Eight, 9. Point 0.41 kilojoule per kilogram. So that is heat input. So now cycle efficiency. Cycle efficiency is, that is the question, cycle efficiency. Efficiency is WNet, network output upon heat supply. Q1. Nine six. Maybe I think this is 32.5 percentage in percentage. So that is the cycle efficiency. For first question, maybe I think cycle efficiency and the network output. That is the first question, right? It is over now, right? Maybe I think maybe most of you, if you are not familiar with the take a printout and should be need to take it for final exam. No. Now some of you have asked questions. Actually, table will be the particular page of the STEAM table will be given to you with the question paper. So not to worry, but for your reference, up to page number 12, you have to get the printout. Otherwise, you can from the library, I don't know, it is available now. This edition is from the, as you know, from the this Bible of the, normally we are calling this book as Rogers and Mayhew Engineering Thermodynamics, Bible of the Thermodynamics. So from that book, actually, we got this table. So you need to get the printout up to page number 12, not all, because it is not, it is very high cost, right? Nowadays, so you can get the photocopy printout up to page number 12, but you can see the final papers before, say, 20, before 18, 17, 18 papers. Now you can see it will carry the final paper will carry the STEAM table, the related STEAM table also. So not to worry, you can directly read from the table. In that case, you are lucky. Why? Because if superheated table is given, then you will get the idea. Yeah, we have to find out the value from superheated table. Otherwise, if all the tables will be given, what will happen? Then sometimes instead of referring the superheated, sometimes you will refer saturated table also. Then it will be confused, very difficult to identify even. So for that side, now only the earlier, actually we have distributed the tables also. Nowadays, due to this paper, nowadays you cannot actually, paper cost is very high, then they are not going to distribute anyway. But the particular page will be attached to the question paper if a question is coming with the use of STEAM table, right? Maybe I think, I don't know whether you can understand, because part B is available. Part B is now you have to work out anyway, but I will show you now. This is earlier, this is this course actually from the final paper in 2018 or 17, I have got this question. But at that time also, it is same syllabus, and then it's a faculty course. So same type of question you can expect, because simple Rankine cycle question you can expect. Carnot cycle is little bit easy. Carnot cycle question I am having anyway. One question is available in Carnot cycle. I don't know whether you, first of all, I have to ask you whether you can get some idea, right? One of you can answer if you want. One of you can answer whether you have understood, referring the STEAM table, why I write this HF plus X into HFG. These steps, actually, I don't know whether you are familiar with these things, right? You can ask me even in Sinhala or Tamil. Sinhala lamai onnang Sinhalen ahana puluwan. උත්තර දෙන්න පුළුවන්. තේරුම් නැත්නම් ගැටලු මොකක් හරි තියෙනවා නම් කතා කරන්න කවුරු හරි. මොකද ආයික මේ වගේ ප්‍රශ්නයක් ආවොත් මොකද කරන්නේ දැන් ෆයිනල් එකට? ස්ටීම් ටේබල් ඇක්චුවලි මේමයි ස්ටීම් ටේබල් ක්වෙස්චන්ස් ගොඩාක් ලේසි ඇත්තටම. ගණන් හදන්න ඉතින් ලේසි. මොකද ටේබල් එක බලාගෙන ඉගෙනට විතරයි තියෙන්නේ. right? කවුරුත් ආන්සර් කරන්නේ නැහැ වගේ. එක එක්කෙනාගෙන් ප්‍රශ්න අහන්න ඉතින් පොඩි ළමයි නේද? නෙවෙයිනේ නේද? අහන්න ඉතින් තේරුම් නැත්නම් ආපහු මීට වඩා ලේසි එකක් මම කියලා දෙන්නම්. ඒ වුණාට ඒ කියන්නේ ගොඩාක් ලේසි එකක් දාන්න ෆයිනල් එකට ෆැකල්ටි කෝස් එකක්. Okay, right. I will show you another question. Now some of you ask question, will this question come in the place of gas power cycle? Gas power cycle is different, right? This is steam power cycle, right? Now you have seen gas power cycle that first day we have worked out this problem on diesel cycle. Those are the gas power cycles, right? Now this is steam power cycle. Now using the steam table, now you have to work out the problem. For the gas power cycle, you don't need to use the steam table, right? Will both question right? Yeah, sometimes you will have definitely gas power cycle and then steam power cycle, both you can have, because you can see the past papers on MEX 3235, both are same, this faculty course, and then those days that course also same, right? So as this time CAT 2 actually you had essay type questions, right? For the CAT 2 you had essay type question, not the structured one. So then definitely you will have essay type questions, right? For thermodynamics, then as well as fluid mechanics, right? Both then the gas power cycle is a different section, and then steam power cycle is different section. So both sections sometimes you may have questions, right? You have to work out both, because that's why I told you gas power cycle, under gas power cycle I have worked out only one question on diesel cycle. So Otto cycle and then dual cycles are there. Then under steam you will have Rankine cycle. Now the problem that I have worked out now is from Rankine cycle, right? Carnot cycle also there. Carnot cycle, if it is an ideal cycle, definitely you can work out problems. I will maybe I think if we cannot find time, I can upload a question with the answer, then you can see, refer that also. And then nowadays now steam table is available anyway, right? On the network, on the LMS, then you can download and then get the printout. So now so far for 2 questions we have prepared, but you have to work out. Now if you cannot see cannot have this, if you are not aware of this steam, by referring the steam table, you can ask me definitely. I can ask Asela Madhushan, innawada? Madhusanka? You can unmute and speak. So if you don't. Right. So both types you can, because at about now I have another 10 minutes because power cut will be on at 7:20, no? Right, 7:20. So till then I can another 5 minutes maybe. I think I can ask if you have any problems you can ask me. Otherwise if I want to now, if you want me to repeat the theory part, then I can do it, but always if I repeat the theory part, because no point of repeating the theory part, because for the final exam you have to work out problems, right? That's why I wanted to show you the problems. Otherwise you will face problems when you do the final paper directly, right? Without with the theory part you cannot answer the final paper, right? So that's why, right?
Mic on kala.
Yeah, discussing the question is better, sir. Right? Okay. Question. That's why I wanted, because last time also I discussed only the theory part. That actually no point on discussing the theory part again and again. So you had to work out problems. So that's why if I upload with the problem and the answer, then actually you will not work, right? For past, some of you are asking past paper answer. No, normally they are not the head of the department. Even nobody is giving the model answer for the past paper. So you have to work out and see. And this is the past paper actually. Now from one of the past paper, I have actually I am working this problem, right? So not to worry. Anyway, if you now I have set of questions and answers, then I will discuss with you these things. If I upload the questions and answers, actually you will not work out any. No point of uploading the question and answer, right? Can you scroll the page? Right. Anyway, recording will be given. Then I will upload the recording. Then you can see the steps also. Right now, only A part actually I have worked out. B part actually you have to work out, right? And then if we have time again, because I have to move to the another section next day, right? So now this recording I can upload it. So today I put the record. Right. Okay. It is available. Then you will get the recording from the LMS, right? But only one question. So one day we are. I thought they will not during the A-level exam period. I thought there won't be a power cut, but still they are continuing, right? So but in maybe I think Wednesday I don't have time. Anyway, Friday I will put the next class, but based on the will be based on another section. But if you have problems, I will work out Rankine cycle, and then gas turbine also I will work out. But the
Hello.
Yeah.
Hello, sir.
Oh yeah.
Sir, me final exam registration වෙන්න බැරි වුණා sir. මොකද කරන්න sir ඒකට?
නෑ ඒක ප්‍රශ්නයක් නෑ. බැරි වුණොත් ප්‍රශ්නයක් නෑ. අපිට දැන් ඔය සබ්ජෙක්ට් එක එලිජිබල් නේ.
ඔව් sir.
eligible නම් ඉතින් ළඟම තියෙන ඒ කියන්නේ ඔයාගේ regional center එක කොහෙද කියලා දන්නේ නැද නාවලදී ඔය center එක කොහෙද නාවලද නැත්නම් ප්‍රශ්නය නෑ මේ පොද නෑ ඇහුවේ ප්‍රශ්නය දැන් සෙන්ටර් ප්‍රශ්නය දැන් මේ ෆයිනල් එක්සෑම් රෙජිස්ටර් වෙන්න බැරි වුණොත් කමක් නැහැ ඉතින් අදාළ සෙන්ටර් එකට දැන් ඔයාගේ සෙන්ටර් එකට ගියොත් ප්‍රශ්නයක් නැහැ ඔය කියන්නේ ලිස්ට් එකේ නම තියෙනවා දැන් නම වැටෙනවා නැත්නම් එලිජිබල් නම් වැටෙන්නේ නැහැ මොකද ඇප්ලයි කරේ නැත්නම් රාජ්‍යනාද එක අන්ඩර් ප්‍රොටෙස්ට් ලියන්න පුළුවන් ප්‍රශ්නයක් නැහැ අන්ඩර් ප්‍රොටෙස්ට්
එලිජිබල් වෙලා තියෙන්නේ ඔක්කොම කියන්නේ රෙජිස්ටර් වෙන්න බැරි වුණා
ඒක ප්‍රශ්නයක් නෑ අන්ඩර් ප්‍රොටෙස්ට් තමයි එයාලා දාන්නේ මොකද ඇඩ්මිෂන් එන්නේ නෑනේ එතකොට මොකද ඇප්ලයි කරේ නැත්නම් ඇඩ්මිෂන් එන්නේ නෑ ඔයා සෙන්ටර් එකට කියන්නේ සෙන්ටර් එකට යන්න පොත අරගෙන එයාලා අන්ඩර් ප්‍රොටෙස්ට් දානවා අන්ඩර් ප්‍රොටෙස්ට් දැම්මොත් එම එයාලා මේ එලිජිබල් බලලා ඔයාගේ පේපර් එක මාක් කරනවා ඒක ප්‍රශ්නයක් නෑ දැන් ඉතින් වහලා කියන්නේ ක්ලෝස් කරානේ දැන් ඉතින් බෑ කරන්න ඒ වුණාට එක්සෑම් එක ලියන්න පුළුවන් මාක් වෙනවා right
ඒක ප්‍රශ්නයක් නැහැ නේද සර් ඒ කියන්නේ
ප්‍රශ්නයක් නැහැ දැන් ඒ අහනවා දැන් ඔයා වෙන සෙන්ටර් එකකට මේ කියන්නේ ඇඩ්මිෂන් නැහැ කියලා වෙන සෙන්ටර් එකකට ගියොත් එයාලා බලනවා දැන් මෙයාව කොහොමද කරන්නේ කියලා ඒත් ප්‍රොසීජර් තියෙන්නේ මේ අන්ඩර් ප්‍රොටෙස්ට් කියන්නේ ඔයාගේ පේපර් එක වෙනම පැක් කරනවා එච්චරයි වෙන මොකුත් නැහැ
හරි thank you sir
හරි then වෙලාවත් so we will wind up for today and then maybe I think Friday I will put the next class so most of maybe I think if you I will discuss another after preparing with the worked example I will show you otherwise it will take time because if I worked or if I work on the whiteboard then it takes time then I will show you with the worked out problem and then parallelly steam table the use of steam table definitely you have to familiarize and then interpolation also you have to familiarize with the these things otherwise if a question comes with the interpolation then you will be left right you have to omit this question right okay thank you very much we will meet again on